Every modern tank begins its life here, not on the battlefield, but inside massive factories where raw steel is handled like something alive. And these steel slabs will soon become armor designed to survive the most extreme combat conditions. Before shaping begins, every steel plate is inspected as advanced scanning systems measure thickness, density, and internal structure, because a single flaw at this stage could compromise the tank's survivability during combat. Laser cutting machines slice through armor steel with incredible accuracy, and the intense heat creates perfectly shaped components, ensuring every armor plate fits exactly where it's needed on the tank. Plasma cutters then form complex angles in the armor, and these angles are not random, as they are designed to deflect incoming rounds, increasing protection without adding unnecessary weight. Once cut, armor plates move slowly through the factory, and this controlled pace reduces errors while ensuring each piece remains perfectly aligned for the next stage of construction. The hull frame is assembled first, as robotic cranes position armor plates with extreme precision, forming the armored shell that will protect the crew and vital systems inside the tank. Robotic welding arms permanently bond armor sections together, and these welds must be flawless because they form the structural backbone of the tank's protective hull. After welding, joints are carefully inspected while sensors and lights search for imperfections, ensuring the armor can withstand powerful impacts in extreme battlefield conditions. Hydraulic presses bend armor into angled shapes, and this geometry helps deflect enemy fire, making modern tanks more resilient without relying solely on thicker steel. The completed hull now stands ready, and at this stage it is an empty shell, waiting to be transformed into a fully operational war machine. The engine is assembled separately, designed to move tens of tons of steel, and this powerful system will determine the tank's speed, endurance, and overall battlefield mobility. Transmission systems convert engine power into controlled movement, and precision here is critical, because smooth power delivery allows tanks to maneuver across difficult terrain. Fuel lines, hydraulics, and electronics are installed next, allowing the tank to function as one integrated machine rather than separate mechanical parts. Cooling and exhaust systems manage extreme heat, because without proper heat control, even the strongest engine could fail under prolonged combat conditions. Lowering the engine into the hull requires millimeter-level accuracy, and once installed, the tank gains its heart and primary source of power. The turret is built independently, a design that allows maximum firepower while maintaining heavy protection for both crew and weapon systems. Cannon barrels are machined with extraordinary precision, as accuracy on the battlefield begins here long before a single round is fired. Auto-loading systems automate ammunition handling, reducing crew workload and allowing faster, more consistent firing rates during combat. When the turret is mounted onto the hull, the tank finally becomes a complete combat platform, combining protection, mobility, and firepower. Stabilization systems are then tested to ensure accurate firing, even while the tank is moving across rough terrain. Suspension systems absorb shocks from terrain and explosions, protecting internal systems and improving crew survivability. Tracks are forged link by link, and each one must endure massive stress while supporting the tank's weight. Once installed, tracks allow the tank to move where wheeled vehicles cannot, including mud, sand, and rubble. Balance testing ensures stability at speed, because even minor misalignment can affect control during combat maneuvers. The tank moves for the first time, and the slow test confirms that all mechanical systems work together correctly. Armor testing then pushes steel beyond battlefield limits, and only armor that survives these tests is approved for service. Weapon calibration uses lasers to achieve extreme accuracy, as precision here determines success in real combat scenarios. Engines are tested at maximum output to ensure reliability under the harshest operational conditions. Final inspections search for hidden flaws, and nothing is overlooked before approval. What began as raw steel now stands as a modern battle tank, built through precision, power, and engineering discipline.